Alright, hey guys, welcome back to another episode. I'm going to do probably going to be a little boring for some people. I don't think it's going to be very exciting just because of the fact that it's a relatively cheap toy. It's pretty expensive when you look at the internals inside of it. There's not much to it. This is a little projector light that my daughter had, and it's something she doesn't use anymore. It's broken. It has got a magnifier on the top. It has another magnifier here on the casing itself. And what this is a little projector. Used to snap up here like this. It would sit there, and basically what you would do is draw on this with a set of water-based markers, like dry erase markers. So you would have a film that you would put underneath this little notch right here, so it would protect this very top cover, and then you would draw on it, and whatever you drew on here would project it up on the ceiling. And these are the holes for the markers to sit in. It takes some double A's. I believe there's 4 of them inside of it. The LED does work. It still works. But since she doesn't use it anymore, I figured it's electronic. Let's tear it apart. So let's take off this brace here. Let's flip this over. Go ahead and poke through these pads here. Battery compartment. Let's leave the battery compartment off. Let's see first. Let's pull this off its little stand here. I'll set this to the side. I could probably use these little magnifiers in further projects. Those are pretty handy. So let's flip this over now. Get screws everywhere. Let's look at that, and like I expected. Going to be a little single LED inside of here. They use some hot glue, try to hold everything down, and then they switch on the outside. So it's, yep, pretty darn bright. So let's go ahead and pull these double A's out of here. And there's also a power little DC jack on the back here. It's 6 volt, 150 milliamp. So not too bad. Go ahead and pull these batteries out. Like I expected, 4 AA. Put this back over. Now let's take this little LED out. Let's just play with this. Now they didn't do a whole lot in here. Obviously it's not fused, it's a low voltage little electronic. Now that is interesting. Instead of having the injection molding with the little Phillips threads, those are metal threads, instead of having that built inside of this injection molding, it looks like they're using this to just hold it on the top to hold those threads in. Let's take that apart. That's weird. I've never seen a piece done that. Yep, they did. So what they did is they just cut out a section for that little bolt, and they used that to put it on top and hold some. Yep, there it is right there. Yeah, little bolt right there. That's pretty ingenious. That's a way to save a little bit of money on manufacturing. So that's a little LED. It's going to be in there with. That's all 4 wires. So what they did is they ran the negative terminal over to the 5-volt jack, which is also spliced in with that negative that runs, let's see, runs back. Let's see, back over to the LED. Okay, just got that stuff on it. So, yeah, you've got, okay, I see what they did here. I thought for a minute there they soldered 3 wires onto this LED, but they didn't. They put some hot glue on there just to hold this wire on there so it doesn't just flop everywhere. Or that way it doesn't pass in front of the LED, you shake it and get in front of the LED and cause any interference and obscure the lens here on this LED. So you've got 2 wires that come off of this. One's going to the DC jack. The other one's going to the switch so they can turn it on and off. And that's just going to be a little cheapo switch there. Yep. It's pretty neat. The switch actually is stamped in the stamp on it says toy, T-O-Y. So I don't know if that's a manufacturer or if that's just letting you know this switch is made for a toy. So let's just have a little tiny SMD resistor, and it looks like it is. Let's use one of these little magnifiers. This'll help me out. It is a 300K resistor. So let me warm up my soldering iron and let me unsolder this. We'll play with that little LED. Okay, before we tear this apart, I want to see how much this bulb actually draws. So what I'm going to do, get out my cheapo little multimeter here. And let's put the battery back in. Oh, there goes the screw. That was the nut. I'm not going to need that anymore. Let's go ahead and put batteries back in just to see. See what kind of power we're getting out of this thing. I don't know if these batteries might not be completely full, or they may not be of the best charm. Wow, that is a bright little LED. Let's see here now. Let's go ahead and put this on. Right, I'm sure it's not going to be anything over 20 volts. If it is, I would be surprised. There'd be some kind of circuit hiding in here somewhere. So let's go ahead and clamp this. Let me bring my little clamp out here. This will just make it a little bit easier to probe. Put this right here. There we go. Reverse my. Getting 5.42 volts. So let's see here. Those are, I guess those batteries would be about fully charged. All right. Let's go ahead and cut this wire. And let's send it down. I want to see how much this is drawing. Let's go ahead and put this on. Let's go ahead and put it on 200 milliamps. I seriously doubt that it's pulling that much, but we'll go ahead and do it this way. Okay. Get that one strapped. Doing this the old-fashioned way. Oh, pulled that one off. Oh. Broke it off again. I guess the old-fashioned way is the reason why they call it old-fashioned. Because they don't do this anymore. Let's go ahead and see. Pull that. Alright. That will be enough. Now, let's see. Let's turn this back on. And let's see how much this draws. Really? That's interesting. Am I really getting? Let me go ahead and reverse these leads then. Oh, it doesn't make a difference, but I like to see the numbers all even. I like to see it in the negative. I like it positive. Is that really 70? Let's see. Yep, it's not reading there, so it's over 20 milliamps. It's over 20 milliamps. 70.4 milliamps? Wow. That's actually a little higher than I thought it was going to be. Let's, just for giggles. Yeah, it's way going to be above this. So yeah, well, they're actually putting a little power to that. Yeah. Looks like right at 70. That's pretty neat. Let's go ahead and turn this off now. Now we will, let's see. Well, let's keep it this way. Let's go ahead and just cut this. Let's hook up to the power supply. Get some leads here. Go ahead and separate this and turn this off. Set this over here to the side. Now, let's go ahead and put this on the power supply and see what we can do. See how much power we can get out of this before we pop it. Alright, let me get some leads for it and we'll hook it up. Okay, and by the power of TV, we are back. Everything is hooked up and ready to go. Let's go ahead and turn this power supply on. I'm going to start out, let's see when it starts glowing. The amperage is all the way off, or it's all the way down on the volt, or on the power supply, I'm sorry. We are at 5 volts, and let's turn this on. Oh, there it goes. Alright, let's go all the way down to when it first comes on. That is going to be, alright, it is just starting to glow at 2.3 volts. Let's see. Not showing any milliamps there. Let's turn it up a little bit. Okay, there we go. 0.8. And that's at 2.5. So let's go up to 3. There's 3.1. We're getting 11.6 milliamps. Let's go ahead and let's bump it up to 5 volts and see what we're getting there. And it wants to stay right around 4.6 volts. And that's 4.2. So let's bump this down a little bit. Let's turn up the amperage then. Okay, 4.6. Wait for it to drop a little. Okay, 4.6. And let's turn up the, see, 46.5. So let's start turning up the amperage. There it goes. Okay, well, they're at, see, right there. Okay, so at 4.7 volts, we're just, let's just shy of 50 milliamps. And that seems to be lighting pretty good. Let's go ahead and bump the amperage up on that. Okay, so the amperage on my power supply is all the way up, but I'm sitting at 4.7 volts. So it's not going to push higher until I go up. There we go. Now we're going to start going up a little bit more. Let's go ahead and bump up to 5 volts. 5 volts right there is 56.2 milliamps. Let's keep going. Let's see how high we can get this bad boy. There's 8. Okay. There's 802 milliamps. No, I'm sorry. That's 80.2 milliamps. Let's keep going. Power supply just kicked on. There we are. We're at 182 milliamps. And that is at 10.1 volts. I'm surprised this is actually handling this amount of power. Let's keep going. Let's go until it pops. Let's see what we can get a height of. And my multimeter tops out right there at 200 milliamps. And we are at 200 milliamps, and that is extremely bright. And that's 10.7 volts. Let's keep going a little. On my multimeter, it says I'm at 220 milliamps at 12.2 volts. So let's keep going. Ooh, now we're starting to see a little smoke. Can you see that? Yep. Now we're seeing a little smoke. That bad boy is heating up. Let's keep going. 13.6 is 2.6. Oh, I heard a pop. 14.1. Let's keep going. 15 volts at 280 milliamps. Now we're starting to get a different color out of the LED. Look at it turn into blue. Let's keep going. Oh, there it goes. 16.5 volts. And, it wants to try. And it, look at it going. Let's go ahead and crank this power supply all the way up. Alright, now we're at 19.4 volts. And let's see. Amperage on the power supply is all the way up. But I don't think this is going to last any much longer. My multimeter is freaking out. I guess all it's going to do is just sit there and flicker. People usually pay a lot of money to get an LED to do that. I think that LED is done. It is not doing much. Let's see. Yeah, we can still get it to stay pretty solid. But now, around 10.7 volts, it starts blinking. Let's bump that down a little bit. Let's stay solid. Now that is not anywhere close to being as bright as it was. And we've only got 121 milliamps going through that at 9.1 volts. Look at it. Looks like it is slowly dying down. Yeah, you can see the milliamps on the multimeter going down as well. And that's staying at a constant 9.1 volts. So that little LED was pretty stout. It took a lot more than what I thought it would actually take. Let's see. And it is still going. Now I wonder if that was the LED that was smoking or if that was the resistor. I wonder if we were burning up the resistor. Yeah, we're at 120 milliamps and it is still going down. Let me go ahead and power this down and let me go ahead and bypass that resistor and see if maybe we were just burning up this resistor on the back here. Let's see. Yeah, looks like it got pretty hot. Yep, let me get the old soldering iron out and let's see if we can go ahead and bypass this resistor on here. Maybe that resistor was limiting us from popping this thing. I seriously doubt it, but that may have been the thing that was smoking. So let me turn on my soldering iron here. Heat this bad boy up real quick. And we'll just put a solder bridge across that. We'll just go ahead and solder it straight across. But I do believe, yes, yep, that resistor is gone. If you can see that, you guys probably won't be able to see this, but let me pull this off of here real quick. Let's see if I can get this. No, there's not enough light, but this resistor is solid black. The numbers that were on it are completely melted now. Alright, let me grab a little bit of solder here. this off. And grab the trusty soldering iron. Okay. Get that fresh solder off of there. Let's go ahead and see if we can pop this resistor off. Okay, got the resistor off. Put that in there. Let's just see if we can get a solder bridge all the way across this. Probably not, but we can try. Let's see. Oh, almost got it. Let's see. There we go. We got ourselves a shoddy little solder bridge there. Let's go ahead and tin this back up. Some fresh solder, and we'll turn this bad boy off. Don't want to burn up that tip. If you're wondering, I was using this soldering iron at 375 degrees Celsius, I believe. Yep, 375 degrees. See, so let's go ahead and flip this little LED back around now, because I think what we did is just burnt up that resistor, but I'm sure we did do some damage to this LED. So let's go ahead and let this hang, if it will. I'll put this back on 200 milliamps. I'm probably going to exceed that 200 again, but let's try. Alright, with the amperage cranked all the way up on this power supply this time, let's go ahead and start turning this on. See where we get our glow at. Right there at 80, not 83 milliamps. Well, it's going down. At 86 milliamps, we've got a small glow. I bet you guys can see that. And that's at 3.4 volts. So let's go ahead and crank it up to the 5 volts. Oh, no. I think I popped it. Nope, there it goes. Flickering again. Yep, I think I've done it. I'm at 19.4 volts on my multimeter. I'm getting 0 milliamps across that now. Yep, I think she is done. Well, hope you enjoyed this video. Please like and subscribe, and I will do some more coming up. Thanks.